This is Algebra 1, Lesson 10-10, Graphing Quadratics in Factored Form. Today's date is Monday, April 20th, 2020. So our objective today is to graph parabolas when given a form that's factored or in vertex form, and it looks like a times the quantity of x plus h quantity squared plus k. So if it looks like that, this is your lesson. And as I announced earlier in our Zoom meeting, this is a 2-day lesson, which means the notes are just today, and then the homework assignment, that's just tomorrow. So you don't have to do the homework assignment tonight unless you want to get ahead, I suppose. So when you meet tomorrow, then we will be immediately starting the homework with no lesson. This is the lesson for the homework tomorrow. So let's talk about the parent function. And what do I even mean by parent function? I haven't really talked about this very much. A parent function is just the starting function, the most basic OG function that you can get here. And for quadratics, that's x squared. I mean, it has a square in it, and therefore it's a quadratic. That's the definition. So what does this parent function look like? So I don't know. Let's go ahead and start plugging things in to this x. I can plug in 0. 0 squared is 0. And by the way, this f of x, if it starts annoying you, you can think of this as it's just y. It's a fancier way of saying y. It's the ability to put f of x versus g of x versus h of x can distinguish between certain functions. That's why we use that function notation. And there's a few other reasons too. Once you hit calculus, it'll make more sense too. What other numbers can I plug in for x? I can plug in 1. 1 times 1 is 1. So I plug in 1, get 1. Okay, nothing interesting happening here. And I should note also that each of these is a coordinate pair. 0, 0 is this point right here at the origin, and then 1, 1 is that point right here. What else could I plug in? I could plug in 2. 2 squared. Okay, finally some new things happening. 2 times 2 is 4. So I go 2 in the x coordinate, 4 in the y coordinate. So I go 2 in the x coordinate, and I go up 4 in the y coordinate, and I get this point right here. Okay, so it's definitely not a straight line, and you know that it's going to be a parabola. That's what we've taught. What about some negatives? Let's try some negatives. Negative 1. Negative 1 times negative 1, or anything squared, is always positive, so it's going to be a positive 1. So I go negative in the x direction, positive in the y direction. I have a point, and then I can try negative 2, and I'll get positive 4, because negative 2 times 2 is, or negative 2 times negative 2 is positive 4. And you see that there's this nice symmetry. We've talked about this before. And it's kind of the symmetry over this line that goes through this vertex. Again, this point down here is called the vertex, in case we forgot. And it's one of the more important points when we talk about parabolas. Let's try just 2 more points. Let's try 3 and negative 3. And I think you can kind of figure out the pattern from there. 3 squared is 9. Negative 3 squared is also 9. So preserving our symmetry, we have a point up here, and we have a point up here. And then do your best attempt to try to sketch a line that goes through here. Let me use a different color to make it pop out more. Oh, man. And then it should be slightly curvy down here, not a sharp corner at all. And that was my attempt at having a nice curve. And it doesn't end at these points. It goes up forever and ever towards positive infinity for the y. So its range is from 0 to positive infinity. And actually its domain, in terms of going left and right, it goes all the way to the left and all the way to the right if you give it enough time. That's our parent function, and you need to have this parent function memorized in order to do this lesson. So if you want to take a few minutes to be like, okay, yeah, all that makes sense. Okay, a vertex is always at the origin. All right, here we go. We're jumping into some harder stuff. So we are going to be graphing this monster. So this quadratic it's kind of the general form of a quadratic. What do each of these letters do? And we don't know. So normally this is something that I say, open up Desmos and try this on your own, and I'll go ahead and say it as well. But I know most of us just want to watch the video and be done with this, so I will do it with you. But I totally, you can follow along for a little bit. Let me pull up Desmos, and I'm going to type in this equation exactly, and you can follow along with me, and then I'll tell you this is the point where you can pause and do stuff, right? So say f of x is equal to a times x plus h quantity squared plus k. And then notice that after we're done typing that in, if you just hit enter, if you click all, either way, they'll enter sliders here for us. So now we have this exact equation down here. I'm going to go ahead and hide this. I can make this a little bit bigger. All right, so what's going on here? Quadratic, weird things are happening. I'm also going to make it so that I'm only graphing integer points. I'm not going to graph, like if I drag this, I might get to 1.7. I just want whole numbers. So I'm going to say my step is 1. The way that you do that is you click on 10 or negative 10, and you just come over here to the step and enter 1, then go to the next one. 1. What that does is now I'm locked into integers, which is pretty nice, because most of the things that I would say like half of the functions we're dealing with are integers. The only case that you'll not have an integer is when this a out front is like a fraction. Like sometimes I'll have 1/3 like in our examples today, or sometimes it'll be 3/2 like in Khan Academy. So with that, let's go ahead and play around with this. Let's go ahead and say that a is 1, h is 0, and k is 0. That's like the most basic function, and this should now look like our parent function that we had up here. They look the same. I can have them side by side. Yeah, that's how my curve was supposed to look, but that's why we have technology, right? So what does each of these do? So let's go ahead and pause the video now and maybe figure these out on your own so they make more sense. So what does a do? If I drag a, oh, it gets skinnier and skinnier. What about if I go the other direction? 0, okay, well that makes sense. 0 times anything is just 0, the constant function. And negative, oh, it goes down instead of up. And even if it's a bigger negative number, it seems to get skinnier and skinnier and skinnier. What we call this in mathematics is it's called vertical stretch. So when I have a bigger number, I can't show you my hands, but pretend this mouse is my hand. I'm pulling it up. I'm stretching all the heights up. Another way of thinking of it is I'm multiplying the heights by this 4, which makes sense too when I have a negative number. I'm multiplying the heights by negative 3, so they were positive in the parent function that I had back here, but when I multiply them by a negative, they flip down here. Okay, well let's make that go back to 1. So what does h do? Maybe we should write these down so we don't forget. What does a do? So the name that you need to know is called vertical stretch. So I'll say vertical stretch. And this is vocabulary that I will be using in future videos. So if I say vertical stretch, you'll be like, oh yeah, he's talking about like that number, that coefficient out front. But what does it do more importantly? That's super helpful for today's lesson. So a, it makes the function, it stretches it vertically. Maybe you can just do picture it. It makes it go up and down is maybe the wrong way to think of that. I think just multiply heights. We'll say this multiplies heights. Because really, I think the main understanding that I want you to come away from today's lesson with is this f of x, I interpret that as the height. So I'll come over here and say this f of x, this is the height. The height. Or if I was being more formal, I would say the y coordinate, but I think the height makes more intuitive sense to me at least. And you can totally translate this into being more formal and saying the y coordinate. But the height is, well, I'm multiplying that height. Everything over here is going to be doing something to the height. I'm now multiplying by height because a is being multiplied by this parentheses. So if I'm going to have adding a k, we can probably assume that I'm going to be adding height. I'm going to be moving up or I'll be moving down. Let's go ahead and check that hypothesis. Sorry for hitting the microphone there. Let's check that hypothesis. So if I move k, if I move it up, predict what's going to happen. If I move k to 1, oh, it goes up 1, to 2, to 3. And if I go negative, it goes down. So again, that makes sense. What is k doing to affect the height? It is just translating it up and down on that vertical line. So I'm going to call this thing the vertical translate. We'll call this and do blue. So vertical translate. And that's the words I'll be using. But what does it really do? It add versus subtract to the height. So it'll be going up or down. Okay. And finally, x is just a variable, right? We always have some sort of x, just like we had in the parent function. But what does this h do? So that's the last question that we have. And again, to come back to our desmos.com/calculator, it's not /scientific. I should have pointed that out from before. But what does h do? So when I drag h, predict what's going to happen. It's inside the parentheses. And this is the hardest bit, which is why I left it for last. What does h do? Predict. Think is going to happen. All right, so I'm going to move it to the right, which means the numbers are going to get bigger. Ready? And bigger. What? Okay, it goes left. Okay, which means if I go negative, it should go, okay, the other direction, which is weird. It's the opposite. And it's going left and right, which is not a height. which is why this is so confusing. I just said over here, everything that happens over here has to deal with the height. So how does coming back over to our graph, how does moving h just move it left and right? That's not the height, that's the x coordinate, that's not the y coordinate. Why does this make sense? And let's analyze this a little bit more, because this is the hardest bit of the lesson here. So what's going on here? The hardest bit of the lesson is understanding why this is, and I'll write it down for us so we can actually take some notes. This is the horizontal translate. I can't write horizontal translate. And it goes left or right. And the other thing that we notice is it's the opposite. So if you have a minus sign, you'd think you'd be going left, but you go right. If you have a plus sign, you'd think you'd be going right, but you go left. So it's the opposite, and that's kind of the key part. And this is something that's going to happen over and over again in mathematics, especially if we studied absolute value functions. Whenever we have parentheses or absolute value or something that's a quantity of x, it's always going to be the opposite, and it's always going to do a horizontal translate. But why? That's the main question. And again, if you want to skip over this in the video, we have all the components to graph this now, but I want to explain the depth, the mathematics of why this makes sense. So if I think about just the function y equals x plus 1 quantity squared, nothing else. So I don't have a k, I don't have an a, I'm just focusing only on that hard bit. If I only have this, my question is the height, right? Y is the height. How can I make this height 0? Well, I can make that 0, and I can go ahead and just do a little bit of math, right? So I can do some substitution. I can be like, okay, yeah, 0 is equal to x plus 1 quantity squared, and I can square root both sides. Well, the square root of 0 is still 0, so I can show my work, I guess. Square root of 0 is still 0. Square root of that side gets rid of the square, and 0 is now equal to x plus 1. Subtract 1 on both sides, and x is equal to -1. And this is kind of that key building block. Wait a sec. We took the opposite. When I have x plus 1, and I can even show you this on a graph too, when I have the equation y is equal to, in parentheses, x plus 1 in parentheses squared, this, and I'll unshow this one, so this is the graph that I'm graphing right now, it went to -1. Why? Because the height is 0. Height of 0 means that it is the x-intercept. So, and that's the other definition, right? The x-intercept is when y is equal to 0. So it's matching all the stuff that we've talked about before. So in order to get a height of 0, in order to get the x-intercept, I have to set this x plus 1 squared equal to 0, and then you'll end up unsquaring things and eventually subtracting 1. You'll take the opposite of whatever's inside. It's a very long-winded way of saying this will always give you the x-intercept. It'll be the height of 0. And we've talked about this before. That height of 0 is just called a 0. All right, well, I don't know if that made too much sense, but there's the depth of why we take the opposites, why this moves it left and right. It's trying to find the zeros, trying to find the x-coordinate of that vertex. So here's a procedure for all these problems today. First, you're going to graph the vertex and some other point. And that other point, you might have to change which point you choose depending on how hard of a function it is. In example 1, I made it pretty straightforward, but example 2, it is a little bit tricky. I can't just choose a nice point because it will eventually come out bad. Well, maybe not bad, but Khan Academy doesn't like it. And then the second step is to apply transformations following PEMDAS. And if you remember parentheses, exponents, multiplication, division, addition, subtraction, you have to do that in the correct order. I'll talk about that in a second, but step 1, you have to graph the original function from this guy. You have to start with the parent function. So the fill in the blank word here is parent function. Let's try it out. So example 1, we have to graph this thing, and this is super based on Khan Academy. Like, it's going to give you probably 2 or 3 numbers. In this case, I gave you all 3 of them were filled. And we're going to first graph the parent function. So ignore this equation. Pretend I didn't even give it to you. Just graph the parent function. So I gave you some room up here in the notes if you printed them out, or you should be giving yourself room and you're copying them down. Above the graph, I'm going to say, what am I actually graphing? Here, I'm really graphing y equals x squared. I'm not even graphing anything yet over here, just the parent function. And again, the parent function goes through the origin, it goes to 1, 1, it goes to negative 1, 1, and that's it. I only really need 2 points. I graph 3. I went above and beyond, but it's not that hard, right? We have symmetry, and we know that the graph roughly looks like that. And we can put arrows at the top to say, hey, it goes on forever and ever. Perfect. So now let's graph the next thing using PEMDAS. I just did step 1, check. Now I'm on step 2, using PEMDAS. And again, I start inside the parentheses, P, which means first I'm going to deal with this set of parentheses. Well, that means I'm going to be graphing y is equal to, in parentheses, x plus 1 quantity squared. I'm dealing with the parentheses now. So how do I do that? Well, remember, up here, when we have a plus 1, it's going to shift it left or right, and it's going to do the opposite of whatever we think is happening. So this is either going to go left or right by a unit of 1. So I have my original points. Each of these points, in fact, you have an infinite number of points, right? But each of these points is going to go either left or right. So I have plus 1. I think it's right. It's the opposite. It's left. So I'm going to go left 1. So if my coordinate used to be at 0, 0, it's now going to go left 1 over to negative 1, 0. So my new point is right here. And again, this point moves over to negative 2, 1. So this point up here comes to negative 2, 1. And there's my new parabola. And all that's happened is my parabola has been horizontally shifted to the left by 1 unit. Okay, next step in PEMDAS. Exponent, well, we don't have to really deal with that. Multiplication. Yeah, so multiplication is this negative 2. This negative 2 is multiplied by this entire quantity. So that's the next thing I'm going to deal with, which means the next graph I have is y is equal to negative 2 times the quantity of x plus 1 quantity squared. So what is happening now? I'm starting with this function now, and I'm going to multiply each of the heights by negative 2. This is saying all of the heights have a height of negative 2. Or all the heights are being multiplied by negative 2. Sorry about that. So this height, this y coordinate is 0. So 0 times negative 2 is 0. Anything times 0 is still 0. So it doesn't move left or right anymore. It's only going to be multiplied. It's only going to be vertically stretched. So this still has a height of 0. It doesn't move. The vertex has not moved. What about this one? This point right here had a height of 1. But now 1 times negative 2 is negative 2. So this height was here, and it's going to move down to negative 2, which means on the actual graph, I have a height of negative 2. The x-coordinate doesn't move, it's still 0. The x-coordinate over here is negative 2 for this point, but that point also will have a height now of negative 2. Again, I don't just take this number. I have to multiply whatever I'm given and multiply that by whatever number is here. And there are my points. And notice I'm going above and beyond. I'm doing 3 points. You only have to do 2. You have to do this vertex, and maybe just I chose that one randomly, or maybe I chose this one randomly. And then go ahead and graph your parabola. Close enough. All right, and then finally, the last thing that I have to do to complete my equation is get that plus 3, which falls in PEMDAS. It's the addition here. So we've done parentheses, multiplication, addition. They might be switched around. Usually these two will only be the two that'll switch around. You'll always have parentheses. You'll always have multiplication. You'll always have either addition or subtraction. So writing our final equation here is y is equal to negative 2 times the quantity of x plus 1 quantity squared plus 3. That's the key difference now, which means every single one of the points, they're an infinite number. We chose 3. You only have to choose 2. Each of the points goes up 3. I added 3 to the heights. So this had a height of 0, and it's going to go up 1, 2, 3. That's its new resting spot. So it's going to go up here. That's my new vertex. And again, this has a height of negative 2. The x-coordinate doesn't change. It's still on the 0 for the x-coordinate. It's going to go up 1, 2, 3. So it's going to have a height of 1. Similarly, by our axis of symmetry, I'll have a height over here. The axis of symmetry runs through the vertex, remember from our first lesson. And now we're done. We've graphed this parabola. And I think I can read your mind. You're thinking that was a ton of work. And it is. And there are shortcuts. I don't want to talk about them until the very end of the video, so stick around. But yeah, anytime that you have these types of functions where you have to graph multiple pieces, it's going to be like this. And you'll see this again in Algebra 2, not necessarily in geometry because we don't do very many graphs, but in Algebra 2, we have exponentials that we have to graph with the same process. We have many other types of functions that you're going to be doing this over and over and over again. All right, let's move on to a slightly harder one. Example 2, and then we'll be done. I know this video is already 20 minutes long, so here we go. Again, graph the parent function. So parent function is going to be y is equal to x squared. You should know how to do that. 0, 1, 1. And I'm just going to graph 3 points again. I don't want to do too many. I know you only have to do 2, but I'm going to do 3 just to make sure I know what I'm doing. I know that that's supposed to be a little bit more curvy, but whatever. Khan Academy, you only have to graph a vertex and some other point. Next step is I have to deal with the the parentheses, so this -2 on the inside. So I'm not going to have y is equal to x minus 2 quantity squared. And what is that going to look like? So it's going to move right 2. It's going to go opposite 2. So I used to have a height or a point here. It's going to go right 2. So it's going to be over here. And then again, up, right, left. So yeah, up 1, right 1, left 1, up 1. And I have my basic parabola. I don't know why I haven't said this yet, but on Khan Academy, you only get one graph. I'm doing all of these 4 different graphs to show you my work, but on Khan Academy, you have to change the points over and over and over again on the same graph. And I realize I should have put this table down here because this is where we're going to need it, but oh well, I'll fix that for next year. Now let's do the next step down here, which is the 1/3, and that's the thing that's going to trip us up. So y is equal to 1/3 in parentheses x, what did I say, minus 2 quantity squared. And then I might as well do the last one. Y is equal to 1/3 x minus 2 quantity squared. And what was it, like +1 or something? -1. -1. Okay, so we have all 4 of our graphs. Let's go ahead and see what happens. So again, this 1/3 is saying I'm going to multiply the heights by 1/3, and it's pretty straightforward. Like the vertex has a height of 0 over here, so 0 times 1/3 is 0, so it doesn't move. It's the same vertex. However, if I graph 3 comma something, well, it used to have a height of 1, but I multiplied this height of 1 by 1/3. So the height should be 1/3, and you are 100% correct, thinking, oh, just graph a point right there. It's about 1/3. Yes, you're mathematically good. Unfortunately, there's an additional constraint, which is on Khan Academy, you can only graph lattice points. That is, you can only graph whole integer coordinates. You have to graph 3, 1 or 3, 0. There's no in-between coordinate. So how the heck are we going to do this? And the answer is you're going to have to kind of use a table or use a little bit of logic. I think a table is probably the way to go. Let's go ahead and look at this function and say our f of x is this function for this table. We're not doing the entire function, just the basic one that we're on right now to make it work out. What we said was when we plug in 3, we got a bad height. So if I come back over here, if we plugged in 3 for x, we got a bad height. Why did that happen? Well, again, 3 is going to be plugged into this x, so 3 minus 2 is 1. 1 squared is 1, so this whole quantity right here is 1, and then 1 times 1/3 is 1/3, which is exactly what we got before, so that makes sense. So when we plugged in 3, we got 1/3, which we don't like on Khan Academy. So let's go even farther away from our vertex. Again, I don't want to graph the vertex, because if I do that, I'll just get the height of 0. That's what it means to be the vertex. So let's go even farther away. I went 1 away. Well, let's try going 2 away. Let's try going to 4. What happens when I do that? Okay, so mental math, you guys can stick with me. So I'm plugging in 4. 4 minus 2 is 2. 2 squared is 4. So this entire quantity here is 4. 4 times 1/3 is 4/3. So again, some weird fraction thing happening that isn't nice. So we went 2 away. Let's try going 3 away. And hopefully that will work. So that means I'm going to the x coordinate 5 now to go 3 away. So when I plug in 5, what happens? 5 minus 2 is 3. Ooh, that's a solid sign. So this is 3. 3 squared is 9, which means this entire quantity here is 9. And then 9 times 1/3, or 1/3 of 9, or even better yet, 9 divided by 3 is 3. Whew. Look at that, a nice little lattice point. That's the key step there. So I'm going to go to the coordinate 5, 3. 5, 3. And I might as well talk about the shortcut now, because you will be getting some of these on Khan Academy. How do you know how many points or how many steps to take away from the vertex? Just look at that denominator. So if it's like 3 halves, like y is equal to 3 halves, in parentheses x plus, I don't know, I'm just making up numbers at this point. This 2 means go 2, I'm going to call them steps for lack of a better term. 2, I guess it could be 2 units, 2 units in the x direction, I should say, x direction. From the vertex. And again, the assumption here is to plug in a point. So that's what we're doing up here. When you're making your table, how far away from the vertex should you go? Just look at that denominator, and that will give you your hint. And by the axis of symmetry, if I come back to this graph, if I go in 1, 2, 3 to the right, I can go 1, 2, 3 to the left, and I should have the same height, and indeed I do. You can, again, plug in -1, and you'll see you do get a height of 3. Because you get a -3. -3 squared is 9. 9 times 1/3 is 3. Whew, all right. That was the hardest piece of math that you'll do in this entire lesson, and is part of the reason that this lesson is going to be divided up into 2 days. So there's our new graph. And then finally, the really, really easy step here is saying, hey, all of those heights go down 1. So I had a height right here of 0 and go down to 1. So this height is going to move down 1. Let's go ahead and graph what that looks like. So I go 2, -1. This had a coordinate of 5, 3. It's going to be 5, 2 down here. So 5, 2, and then by the symmetric property of our graph, we also have a point over here, and that is our final graph. Yeah, I'm not the best at drawing quadratics. I need more practice. I've been relying too much on a computer. But there's our graph, and I'm officially done with the lesson, but I think it's worthwhile going over what it looks like to do a problem on Khan Academy. So let's go to student view and try one of these out. So you can totally just stop the video now and try this on your own. So how am I going to approach this problem? And if you get this problem, then you get a freebie. Hopefully this is not like a quiz question or something. Okay, so first graph, the parent function. The parent function looks like that. I go right 1, up 1. Perfect. Okay, the next step is to take this -3, and I don't know why I'm zoomed out so far. Let me zoom in so you guys can actually see what I'm doing. I'm going to go right 3. So each of these coordinates is going to go right 3, the opposite, right? So this goes 1, 2, 3. 1, 2, 3. Okay, this -1 says multiply all the heights by -1. So this had a height of 0, so it doesn't move. This had a height of 1. 1 times -1 is -1, so boom. And then finally, move all the heights up by a factor of 4. So this had a height of 0, and I go 1, 2, 3, 4, and I go up 1, 2, 3, 4, bada bing, bada boom. And that's how you do these problems. Cool. So that concludes a very, very long lesson, and I'm sorry for the length. Hopefully you guys have the depth and understanding that you can do this homework tomorrow. I'll see you guys tomorrow.